All right, so the last time we were together, we talked about doing a calorimetry calculation that did not include the calorimeter. Today we're going to do one that does include the calorimeter. And again, I'm just going to look at example 13.3, which I'm assuming that you have already read. But this one does include the calorimeter, so we'll transfer that information to our chart up here. This time, obviously, I don't have that top line crossed out. So we will be using it this time, and we'll go through how to do this with the calorimeter. All right, so I'm gonna, in place of reading the whole problem, again, I'm assuming that you've already read this and gone through the example. So I'm gonna go through it a step at a time and add the information into my chart. So I have a 250 gram sample of an unknown metal. So that will be my mass, 250 grams. Is heated to 350 degrees Celsius. So that will be my initial temperature, 350 degrees. It is then dropped into a calorimeter that contains 1,500 grams of water. So that's my liquid, 1,500 grams of water. And if it's water, I know that the specific heat is 4.184 joules per gram per degree Celsius. And it is then dropped into a calorimeter that contains 1,500 grams of water, which is initially at a temperature of 24.2 degrees Celsius. The water reaches a maximum temperature of 31.2 degrees Celsius. So we'll add that in here. It says the heat capacity of the calorimeter is 1410 joules per degree Celsius. Now, I don't really have a spot on here for that, but if you recall, basically what he told you is that if you just have a heat capacity in place of a specific heat capacity, the heat capacity has already taken into account the mass of the calorimeter. So if they give you a heat capacity, what it has really done is it has combined the mass and the specific heat together. So these two are really combined together for the calorimeter, and the heat capacity is 1410 joules per degree Celsius. So that really spans both of those. And you'll notice if I look at the units down here, this is grams, this is joules per gram per degree Celsius, and when you multiply those two together, the grams cancel out and you're left with joules per degree Celsius, and that's the units that I have up here in the heat capacity, okay? So that's why I'm really just combining those two values together when they say I have a heat capacity for the calorimeter. They are asking me for the specific heat capacity of the metal, which again is this piece right here. And I have a lot of empty boxes, so what am I going to fill in here? Well, the liquid is inside the calorimeter, so it's going to have the same initial temperature as the water will. And we talked before when we did calorimetry problems that whatever the final temperature is, it's the final temperature for everything. So this is going to be 31.2. and this will also be 31.2, okay? So, because I have initial and final temperatures for all three, I can calculate a delta T for all three. TF minus T sub I, remember we always take the final minus the initial. So, for the calorimeter, 31.2 minus 24.2 is 7.0 degrees Celsius. And the change in temperature for the calorimeter and for the water will be identical. The change in temperature for the metal is 31.2 minus 350, which is going to give me a negative 318.8. Again, remember that I told you if you should always have something that's gaining in temperature and something that is losing temperature, because whatever is gaining temperature is gaining heat, whatever is losing temperature is losing heat. So if I look at the calorimeter first, I'm going to take the heat capacity, the 1410, times the delta T. So really all I've got is is this degree Celsius is going to cancel out with this degree Celsius, and I'll be left with joules. So the 1410 times the 7, and that will give me 9,900 joules, two significant figures, sorry. Then if I look at the water, I have 1,500 grams times 4.184 times the 7, and that will give me 44,000 joules. Now again, remember that we said these are the two pieces that are gaining heat. This is the piece that lost heat. So I'm going to take both of these and add them together because they represent the objects in this whole system that have gained heat. And so that gives me a total of 54,000 joules. Significant figures, if I'm adding, this is in the hundreds place and this is in the thousands place. So my significant figure will have to be in the thousands place. Okay, so if the calorimeter and the water together have gained 54,000 joules, where did it come from? It had to come from the metal. So that means the metal has lost 54,000 joules. So I'm going to take that same number, I'm going to put it down here and make it negative. And the delta T is negative, so 54,000 divided by negative 318.8 divided by the mass of 250, and that will give me a specific heat of the object of 0.68 joules per gram per degree Celsius. Okay, so really if you have to take into account the calorimeter, the only additional step that you have to think about is that you have to add the heat for the calorimeter and the heat for the water together and get that total before you can plug it in down here for the metal. Okay, so you'll get some practice doing those kinds of problems today.